Let the points where the tangents touch the circle be P and Q. Let the external point be R. And let the center of the circle be M. The first thing we're going to do is connect the center M to both points of tangency by drawing line segments MP and MQ. Since both of these are radii of the same circle, they are equal, so MP equals 4 and MQ also equals 4. Next, let's recall a very important theorem. A radius drawn to the point where a tangent touches a circle is always perpendicular to the tangent. The reason this works is because the radius meets the tangent at exactly 90 degrees. Therefore, angle MPR is 90 degrees, and angle MQR is also 90 degrees. Now let's use another useful theorem. When two tangents are drawn from the same external point to a circle, the two tangent segments are equal in length. That tells us that PR equals QR. Now let's focus on quadrilateral MPQR. The sum of the interior angles of every quadrilateral is 360 degrees. We already know that angle MPR is 90 degrees, angle MQR is 90 degrees, and the angle at R is also 90 degrees. So the remaining angle, which is angle PMQ, equals 360 degrees minus the quantity 90 plus 90 plus 90. Adding those angles gives 270 degrees, and 360 minus 270 leaves us with 90 degrees. So, the central angle PMQ is 90 degrees. This is an important result because later we will need it to calculate the area of the sector. Now notice that the shaded region is equal to the area of quadrilateral MPQR minus the area of sector PMQ. So our next goal is to find each of these areas separately. To help us do that, let's draw lines segment MR. Now pay attention to what happens here. We know that PR equals QR because tangent segments from the same external point are equal. We also know that MP equals MQ because they are radii, and MR is a common side shared by both triangles. Therefore, triangle MPR is congruent to triangle MQR by the side-side-side congruence rule. Since the triangles are congruent, their corresponding angles are equal. The total central angle PMQ is 90 degrees, so line MR divides it into two equal parts. Therefore, angle PMR equals 45 degrees, and angle RMQ also equals 45 degrees. In the same way, the angle at R is 90 degrees, so it is also split equally into two 45-degree angles. Therefore, angle PRM equals 45 degrees, and angle MRQ also equals 45 degrees. This tells us that triangle MPR is a 45-degree, 90-degree right triangle. Now let's remember a special property of this triangle. If each leg has length 1, then the hypotenuse has length square root of 2. In our diagram, the radius MP is one of the equal legs, but its actual length is 4 instead of 1. So, we simply multiply every side of the basic ratio by 4. That gives PR equals 4, and the hypotenuse MR equals 4, multiplied by square root of 2. Now, let's calculate the area of triangle MPR. The formula for the area of a triangle is 1/2 multiplied by the base multiplied by the height. Here, the base is 4, and the height is also 4 because the two sides meet at a right angle. So the area equals 1/2 multiplied by 4 multiplied by 4. 4 multiplied by 4 is 16, and half of 16 is 8. Therefore, the area of triangle MPR is 8 square units. Since triangle MQR is congruent to triangle MPR, it has exactly the same area, which is also 8 square units. Therefore, the area of quadrilateral MPQR equals 8 plus 8, which gives 16 square units. Great. Now let's find the area of the sector. The formula for the area of a sector is theta divided by 360 multiplied by pi multiplied by radius squared. In this problem, theta is 90 degrees and the radius is 4. So the area of the sector equals 90 divided by 360 multiplied by pi multiplied by 4 squared. 4 squared equals 16, and 90 divided by 360 simplifies to 1 divided by 4. 1 divided by 4 multiplied by 16 pi equals 4 pi. Therefore, the area of the sector is 4 pi square units. Finally, we can calculate the shaded area. It equals the area of the quadrilateral minus the area of the sector. So, we have 16 minus 4 pi. Using the approximate value of pi, this becomes approximately 3.43 square units. Therefore, the exact area of the shaded region is 16 minus 4 pi square units, and its approximate value is 3.43 square units. If you solved it correctly, excellent work. If you learned something new today, don't forget to like this video, subscribe for more challenging mathematics problems, and let me know in the comments what topic you'd like to solve next.